Why does your wall outlet say 120V? And what's the difference between alternating current and direct current beyond just the name? First, you need to understand DC, direct current. Direct current flows in one direction only. For example, batteries do this. It's a constant value. AC, or alternating current, is produced by power plants, and it reverses direction many times per second. In most countries, that would be 50 to 60 times per second, measured in hertz, because that's frequency. It's a wave pattern, while DC is a flat line. And both voltage and current go up and down and even negative over time. And the equations are this. First, for voltage, there's actually two. VT equals V0 sine 2 pi ft. What's each part of this mean? If you've learned waves and oscillations, this might look pretty familiar. There's sine because it's a sine wave. And if your trig is a little behind, go watch my super long trig video. V0 means peak voltage. F is simply the frequency in hertz. T is time. And the other equation, if you pull out this 2 pi f, 2 pi f is equal to angular frequency. So you can rewrite this equation as Vt equals max voltage sine angular frequency times time. These are equivalent, they're the same thing, and they're both on the free cheat sheet in the description. Current also follows a sine wave. So current, the equation is actually the exact same. However, it's current instead of voltage. Imagine the door from a bird's eye view. DC is like pushing this door open and then just holding it in place. AC is like swinging your door back and forth repeatedly with the same strength in both directions. We've looked at voltage and current, but power is given with this equation. PT equals current squared times resistance, right? That's the power equation. This is equal to max current squared times resistance sine squared angular frequency time. These are both equations for power. Power never ever goes negative, even if the current does. Why? Because it's squared. There's an exponent. And squared numbers cannot be negative, but it does fluctuate. And since it fluctuates, average power might be something useful to know. Average power is given with 1 over 2 I squared 0 R, or 1 over 2 voltage squared 0 over R. Don't worry if it looks quite complicated, because when you use these equations in problems, it all makes sense. And you don't have to memorize these if you get the free cheat sheet in the description. This is what matters in real life, not the peak voltage or the peak current, but the effective average. Let me teach you about RMS values. RMS values are the real world version. So to make AC math usable, this is what we define. And it's also why you might see 120V on your wall outlet. And by the way, what does RMS stand for? It stands for root, mean, square. Put it simply, it means the effective value. So the RMS current is the max current divided by root 2, or roughly 0.707 max current. These are the same thing. Same thing for voltage, which I'll write out here. I'll throw these on the cheat sheet as well, but these are called root mean square values. And they are the AC equivalents of DC. It means a DC current with the same I and V values for an AC current will produce the same power. Hence, it is usually the RMS value of current and voltage that's measured or specified, like on your wall outlet or your phone charger. It's not the peak voltage. And let's go through an example problem. Compare what happens when a 1500 watts US hairdryer is plugged into a 240 volt UK outlet. Why do the countries matter? Because US voltage is the root mean square, which is 120V. In the UK, the root mean squared voltage is 240V. So let's compare them. First, let's find the RMS current in the US. RMS current is given with P over RMS V. This is the current formula. The power is 1500 and the VRMS is 120, giving us 12.5 amps. And then how about the peak current? The peak current can be found with the other RMS formula, which was peak current over root 2. So we can rearrange and isolate for peak current, giving us RMS times root 2, which is roughly 17.7 amps for the peak current, 12.5 for the RMS current. From Ohm's law, we can find resistance as V over I. specifically RMS over RMS. VRMS is 120 and the RMS current 12.5, giving us resistance as 9.6 ohms. What do we do with all of this information? Now we're able to find the new power when you plug in your hairdryer into a 240 RMS outlet. So P power is given with voltage squared RMS over R. This is on the free cheat sheet in the description, and we did touch on this earlier, but very briefly. Voltage RMS squared is 240, and then squared. The resistance we found as 9.6. So that means it's now 6,000 watts of power. What does that mean? The hairdryer draws 4 times the power, which will probably melt the coils or trip the fuse. So here's a quick recap. It was a pretty math-heavy lesson, but it's just formulas. AC reverses direction. So voltage and current are both waves and they follow sine. Power oscillates, yes, but the power always stays positive. All of your home appliances are rated by RMS voltage, not peak voltage, and plugging devices into the wrong voltage can destroy them.